A rational function is a quotient of two polynomials. So a function that can be written as p of x over q of x, where q of x is not 0, is a rational function. For example, x plus 1 over 2x squared plus 5x minus 3, or 3x squared minus 3x minus 6 over x squared plus 8x plus 16. This is the simplest form of rational function. F of x equals to 1 over x. So the graph of rational function often have some special properties. We can start looking with the simplest form. F of x is 1 over x. So as this is what it looks like. So at x equals 1, y equals to 1, x equals minus 1, y equals to minus 1. But as x approaches infinity, or x grows larger and larger, the value of the function goes really small. For example, 100.01, x 10,000.001, and x million, trillion, etc. will become really closer and closer to 0, but never get to 0. So the line's gonna approach the x-axis, but never touch the x-axis. So the x-axis is called the horizontal asymptote. Line y equals 0 or x-axis. And the same happened in the negative direction. As x grows larger, it's going to be negative, but also approaches 0. Similarly, when x approaches 0, x cannot be 0, but as it approaches 0, it gets really small. And 1 over a small number, 1 divided by a small number, is going to be really large. So this graph, as it approaches 0, it also approaches the y-axis, but never touches the y-axis. So in this case, that is called the vertical asymptote. So it would be the line x equals 0 or y-axis. So the asymptotes are the line that the graph gets really close but never touches it. Here are a few examples of rational functions and their graphs. Y equals -2 over x, function 2 over x plus 1, function 1 over x squared. This is function x plus 3 over x plus 2. This is a graph of x plus 3 over x squared minus 3x minus 4. This one has 2 vertical asymptotes and 1 horizontal asymptote. This is function x squared plus 2x plus 5 over 3x minus 1. So this one has a vertical asymptote and a slanted asymptote. So given a rational function, we can determine the asymptotes by following these procedures. So first, we can check for the vertical asymptotes by setting the denominator equal to 0. So for example, this function f of x 1 over x minus 2, just set the x minus 2 equals 0 and solve for x. So in this case, x equals 2, so that means the line x equals 2 is the vertical asymptote. So for the other asymptotes, we can check for this condition. So here we look at the degree of the numerator and the denominator. So in this case, for example, this is degree 2, because x squared, that means degree 2, and x fifth, that means it's degree 5. So in this case, the degree of the numerator is less than the degree of the denominator. So that falls into category A, which means there's going to be a horizontal asymptote, y equals 0. This is another example, f of x 3 over x minus 1. So this is degree 0, because there's no x there. And this is power on x is 1, so this is degree 1. So, but since the top is less than the bottom, then y0 is going to be the horizontal asymptote. For possibility number 2, if they are of the same degree, So this is degree 2, and this is also degree 2. So if they are the same, then there's going to be a horizontal asymptote at the line y equals to, we look at the coefficient of the degree, the highest degree, right? So 2 is going to be 205. This line is going to be the horizontal asymptote. The reason being because as x approaches a larger and larger, these 3x plus 1 minus 7 minus 2 is going to grow insignificant compared to x squared term. So at the extreme value, only these matter. And as x approaches a large number, the function is going to approach this value 205. It's not going to be exactly 205, but it's going to get closer and closer to 205. So possibility number 3 is if the top is one more than the degree at the bottom. So this is degree 2, and this is degree 1. So if it's one more, then there's going to be a slanted asymptote. So we can find that asymptote line by doing the synthetic division, and we'll look at an example on the next page. So for example A, f of x plus 1 over 2x minus 1 times x plus 3. So check for vertical asymptotes. We set the denominator equal to 0. So that gives us 2x minus 1 is 0, or x plus 3 is 0. So that means x equal 1/2 or x equal to minus 3. So that means the vertical asymptotes are line x equal to 1/2 and the line x equal to minus 3. So to check the other asymptotes, we look at the degree. So the top part is degree of 1. The bottom part is of degree 2 because it's x times x squared. So the bottom part is degree 2. This is degree 1. So that means there's going to be a horizontal asymptote at y equals 0. For B, example B, f of x is 2x plus 1 over x minus 3. So first, the vertical asymptote, we set x minus 3 equals 0. So that's the line, that means x equals 3. So the line x equals 3 is the vertical asymptote. And for check the other asymptotes, look at the degree. So this is degree 1 and degree 1. Both are degree 1. So since they are equal, then there's a horizontal asymptote at the line y equals 2 over 1, which is line y equals 2. For C, vertical asymptote, set the x minus 2 equals 0, so x minus 2, so line x equals 2 is the vertical asymptote. And this is degree 2, and this is degree 1. So this one is one more than the bottom. So that means there's going to be a slanted asymptote. And we can find that by doing the synthetic division. So x squared plus 1 divided by x minus 2. So the result gives us x plus 2, so and the remainder 5. So we can write x squared plus 1 over x minus 2 equals x plus 2 plus 5 over x minus 2. So this line, the x plus 2, is going to be the line, this slanted asymptote. The line y equal x plus 2 is the slanted asymptote of this function. Go ahead and try these and check the answers.